gana action. Niba ushaka kwiga indimi, gana action. Ushaka kuba umusirimu, gana action.
Hello, my people. Welcome to Action College once again. So thank you so much. As you can see me here, I'm Shadrach Niyomugabo from Action College. So we offer different services. We provide different skills, either in TVET or CANDIDET LIBRE from General Studies. And today, I'm going to be with you and learn with you physics as one of the subjects we offer. So we want to be with you. I'm gonna be with you in or deal with you with this electric circuit. What is electric circuit? Okay, what is electric circuit? So I was wondering how electric circuit is like a relationship. Okay, electric circuit is like a relationship because if there is no connections, to mean there will be no light, right? If there is no connection, no light, right? Okay. First of all, what is circuit? Circuit is a loop or path that allows something to pass through. Okay. Electric circuit or an electric circuit is a closed loop or path that allows electric current to pass through. Okay? Are we together? So a components of electric circuits or the components of or the elements of electric circuits. First of all, we have a battery or cell. We have electric wire. We have resistor or light bulb. So a resistor is something which contains resistance. An example of resistor is a bulb, refrigerator, and other materials which require electric to work, or normally electric materials. And also the third one is switch, ammeter, and the voltmeter. Ammeter is an instrument used to measure current, and the voltmeter is an instrument used to measure voltage. Okay. The current, voltage, and the resistance. If we say current, this current refer to the flow of electric charge, while a voltage refers to the amount of energy, amount of electric energy that requires or that push a flowing electrons. Okay. Resistance refers to the opposition to the flow of electric current. Okay. And what is the relationship between voltage, current, and the resistor or resistance? Okay. Current is the ratio of voltage and resistance. Okay, to me that is equal to voltage over resistance, where voltage is the product of current and resistance. To me, it's equal to current times resistance, and resistance is equal to voltage over current. So from the above relationship, we can see that current passing through an electric circuit is directly proportional to the voltage and inversely proportional to the resistance. To mean, as the voltage increases, the current will increase. Okay? As the current increases and the resistance will decrease. Okay? To mean, at higher resistance and low voltage, we'll be having low current. Okay? Let's proceed. And this is Ohm's law. This have been explained by Ohm's law, where we say that current is equal to voltage over resistance. Let's proceed. So let's see how the resistor are arranged. Okay, there are two ways of arranging resistance in electric circuit. We have in a series and parallel. So keep in mind that in a series arrangement, the current passing in all resistors is the same, but the voltage is not the same. While in parallel, the voltage is the same for all resistances. For this is the same, but the current is different. Okay, are we together? So how we calculate the summation of resistance in a series or electric circuit. Okay. If the resistor is arranged in a series, and we were asked to find the total number of resistance. So this total number of resistance will be equal to the summation of all resistance. An example here, so we take R1 plus R2 plus R3, okay? Right, so a resistor which are connected in parallel, so if you are asked to find the total resistance in a given circuit which are connected in parallel, you will find that 1 over R total or inverse of R total is equal to the inverses of this the inverse of the summation of the inverses of all resistance. Okay, to mean that 1 over R total will be equal to 1 over R1 plus 1 over R2 plus 1 over R3. Okay, let's proceed. Let's proceed with how we can practice this, how this is working. So, okay, stay tuned. So, as I told you, one of the components of electrical circuit is a wire. What happened? This is a wire. So, this is a wire. You see, this is a wire. This is a wire. Okay, and this is a battery. This is a battery. Okay, or a cell, and this is a light bulb or one of the resistor, a light bulb, and I'm collecting. So stay tuned. And this is also a wire, and this is a switch. This one is a switch. You see, this one is a switch. This one is a switch. So I'm trying to show you how we will connect that. And also this is a wire. Okay, this is a wire. I'm connecting those wire. Okay, right. And this is a wire. You can add another cell or another battery if you want. You can add another battery like this, and then you bring another wire so that you can make a circuit. Okay, and this is a closed. This is a circuit battery which is open, to mean that the current is not moving. So to mean the switch is open. Okay, the switch is open. So if I close the switch, to mean I switch on. Okay, you see, we will get we will see the test. We see the light. Okay, and this is the movement of electrons, and you know, electron moving from negative to positive, while current moving from positive to negative. To mean current and electron move in different directions. Okay, right? So from the direction we have seen that current is equal to voltage over resistance. Okay, and if voltage increase, if the resistance increase, current decrease. Okay, as I told you before. So let's see. This is the resistance. We have a resistance which is equal to 10 ohm. If we increase the resistance, to mean the current will be low. Okay, you see the intensity of light decrease. Are we together? So if the resistance decrease, the current increase. You see, then you get higher intensity. Are we together? So let's proceed. Let's proceed with the arrangement of resistor in series and in parallel, right? Okay. Let's proceed with this circuit. We're going to bring another resistor, which is electric bulb, as I told you. This is the first one. Okay, we're going to connect that in a series. Are we together? So I'm going to bring I have to bring another electric bulb. Okay, electric bulb. Put it here. Okay. Also bring another one, like here. Okay. Are we together? Are we together? So let's stay tuned. This bulb are connected in a series. Okay, are connected in what? Are connected in a series. Then I have to bring another switch here. Okay, this one. You see, our circuit contain different resistor. Okay, we have 3 resistance or 3 bulbs. Why? Right? So if we close the circuit, to mean we switch on. So you see, you will see that all of these are doing what? Are produce light. Whether the one which is between is not producing light. The reason why is because it is not connected very well. If we connected it very well, we will do like this. Okay, you see, all of them are producing light, right? And they are connected in a series. So to me, the current which is passing through them are equal, right? The current is the same or are equal, but the voltage is different, right? Okay, I think you understand the connection in the connection of the arrangement of resistors in a series. Okay, let's proceed with the parallel. This one are connected in a series because the current which are moving is the same. To mean the current which is passing through the first one is going to the current passing through the second one, and also the one which is passing in the third one. Okay, let's proceed with the one which are connected in a parallel, right? We have to connect this bulb in a parallel, right? Stay tuned. So this will have to break. Have to disconnect them. Okay, so that you can proceed. Okay, stay tuned. So I have to bring another wire so that I can make it very clear. Okay, stay tuned. Stay tuned. Okay, right. So I have to bring another wire here so that I can make it very clear. So I have to break this. See, proceed. Okay, you see this one is producing light. Okay, producing a light because it is connected. It is already connected. So let's break this one. So we're going to connect that in a parallel. Okay, I have to bring another wire here, right? So I have to bring another one here. Okay, are we together? So stay tuned. Okay, sorry, stay tuned. You see, these are connected in a parallel, right? This one, okay, this one are connected in a parallel, right? Okay, I have to bring another wire here from here. Okay, right? Okay, okay, I have to add a switch so that I can switch on or switch off. Proceed. You see, this circuit is connected in a parallel, right? And is switch off because the circuit is open. It is not producing light. The bulb are not producing light. If I switch on, to mean I have to close the circuit like this. You see, all of all of the bulbs are releasing light, right? Okay. So if I told you in a parallel series is somehow good because the current which are passing among these resistor are different. If I mean the current. So if I disconnect this, the other will continue working. Okay, right? The other will continue working. That's why the arrangement of the resistance in parallel is 100% good. Okay, it's good is better than in a series, because if the one resistor fail to work, the other will continue work. Hope this can you can see this. I hope this can clarify. Okay. Then stay tuned for the next video. We will be dealing with how we can measure this voltage by using voltmeter. As I told you, this is an example of this is a voltmeter, and this is a voltmeter, and this is a meter. Okay. In the next video, we will see how this voltmeter and current, and this voltmeter and ammeter work. Okay, stay tuned, and I try to we always prioritize our students. We need more and more. Okay, thank you so much for your kindness attention. Hope you are still doing very well. Okay, and let's proceed with this one. So as you can see here, the first series, the first circuit is connected in parallel, while the second is connected in series. So, but all of them are open, to mean that the switch is off. If we close the circuit, to mean the switch is on. Okay. If we close like this, you see all of them are producing light. For the first one, which is connected in parallel, but while the second one is connected in series. So let's switch on all of them. So you see the second one is producing low light. Okay, you see low light intensity. Okay, to me that the first one which is connected in parallel produce higher light compared to the second one which is connected in a series. To mean for the resistors which are connected in parallel, the resistance will be too low compared to the one which is connected in a series. Okay. So if one resistor fails to work for the parallel circuit like this, you see the second one is failed to work. This one failing to work. You see this one it is not working, but the remaining one are still working. Okay, but if the one which are connected in a series and the one or one of them fails to work like this, if this one fails to work, you see another also will fail. Okay, will fail, right? To mean the arrangement of resistors in parallel is highly good than others. So for the next video, we will be dealing with how this voltmeter, as an instrument used to measure voltage, work, and even a meter, the instrument used to measure current, work. We will see how of those instruments work. Okay, thank you so much, and I love you so much. Stay tuned with the update from Action College. We prioritize you as our student. Thank you so much.